In this video, we're going to talk about the volume of prisms, cylinders, pyramids, and cones. So for the volume, we just have to remember that that is in cubic units, so it's the inside part of our shapes. If we have two polyhedrons that are congruent to each other, then they are going to have the same volume. For composite volumes, we had composite figures before when we were dealing with area of 2D shapes, but we could also see that with volume. So we have to add up or find the sum of all the individual volumes and then combine them together. Cavalieri's principle is basically saying that if we have two solids with the same height and they have the same cross-sectional area at every level, then they have the same volume. So if you're looking at these three pictures right here, if you notice that some of these are oblique, but as long as the cross sections at all of those spaces along the way, if I slice up into lots of little tiny pieces, that if the area of those different shapes are all the same, then the area of these two prisms combined that individually, that the combined volume will be the same as well. So same would work for the cylinder. If we had an oblique cylinder off to the side, that as long as these circles that make it up, then it would be the same volume inside. For the first formula that we're going to see is volume of a cube, and this is not on the formula chart. So you might want to make a note of that because you'd only have your formula chart when you are taking your test. But if you realize that this is the same as a prism, then you can use the volume for a prism to find the volume of a cube. Here is a list of all of the volumes that we're going to be using for these four shapes. So you have a volume of a prism, cylinder, pyramid, and a cone. And if you notice, we have groups of them that are similar to each other. So those first two are similar to each other, and these second ones are similar to each other because if you notice, they have the exact same formula. But you have to think of what the shapes of the base are. So with a prism, it's usually going to be a rectangle or a square. So the area of the base, you just have to look at the shape of the base. The height, remember, is still the distance between the two bases. For a volume of a cylinder, it's the same formula, so it's still the area of the base times the height, but the shape of the base is going to be circular. So you have to realize that you're really going to be using pi r squared. So an abbreviated version of this would be pi r squared, because that's our b, and then times the h. But this is the version that's on your chart that you get to use on your test. So you need to realize that it's really this variation, but you're going to see it as b times h. The same thing's going to happen down here with your pyramids and your cone because they start with the same thing. So it's 1/3 times the area of the base times the height. And it's not the slant height, it's the actual height. So perpendicular distance that you can see in my pictures right here, the green height. And for the volume of a cone, that is also circular for the circular base. So we need to use this pi r squared. So the abbreviated version for this one would be 1/3. The area of our base would be pi r squared, and then times our height. But remember, this first version is what is on your chart. So you need to memorize the fact that it is a circle for the base and use the area of the circle for that equation. All right, so now we just have a bunch of shapes that we need to find the volumes of. So I've got 7 different total shapes, and we've got some varieties. So in this first one, it is a prism, and it's a trapezoidal prism. And that is because your base is a trapezoid. So whenever it's mentioning the area of the base, we have to think of the area of a trapezoid. So we know it's capital B times H, so I'm going to break it down. So my B is a trapezoid, which uses 1/2 height times base plus base. So when I plug those numbers in, my height of my trapezoid is 3. So it's not of the whole figure, it's just of the base. My two bases, so my two parallel sides in my base is my 14 and the 6 that's down here. So 14 plus 6. So when I multiply that together, because 14 plus 6 is 20, times 3 is 60, divided by 2, I end up with a 30 for the area of my base. Now the h is the height of the prism, so that's this 5 right here. So when we plug everything in, we have the capital B, so that's my 30, times the height of my prism, so that would be 5, and I multiply that and get 150, and this is centimeters cubed because we are using cubic units. All right, on to our cylinder. So our cylinder equation, let's first write cylinder up there. We have capital B times H again, but remember that the base itself is a circle. So we need to use pi r squared for the shape of that base. So let's go pi, our radius is our 9. So this is really 81 pi is my capital B. Then for my little h is the height of the prism, so that's the distance between the bases, and that would be my 6. So when I set up for my volume, I've got my 81 pi times 6, and that gives me 1,526.814, and this is feet cubed. All right, for our next figure down here, we have a triangular prism. And since it's a prism, we have capital B times H again. So my base is a triangle. So I need to use 1/2 base times height. Now realize this is just for the triangle, not for the height of the prism. So for my base and height of my triangle, I just have my 5 and my 9. So the area of my triangle comes out at 22.5, so that's my capital B. Now for the H of the actual prism is my 8 right there. So now my volume of the whole thing, I've got my capital B, so 22.5, times my little h, which is 8. When we multiply those together, it comes out exactly at 180, and this would be meters cubed for our units. All right, so the last of these 4, we have a cone, and that is 1/3 capital B times H. Now, if you notice, we do not have the height of our cone, so if you want to do that first, we have our Pythagorean theorem, so we have A, B, and C. So we're going to have to do 5 squared plus B squared equals 8 squared. And when you solve that for B, we end up with the height being the square root of 39. And I'm just going to leave it as the square root of 39. All right, so for my capital B is a circle again, like my cylinder. So I've got pi r squared. So I really have pi times 5 squared, which is 25 pi. The height of our whole cone then is that number we found before, so our square root of 39. So when we plug everything in, we've got 1/3 times my area of my base, so 25 pi, times the height of my cone, which is my square root of 39. So when we multiply that all together, we get 163.494, and this is meters squared. So for this very first picture on here, we have a pyramid, and if you notice, it is a triangular pyramid. So for my triangular pyramid, I know that my equation for volume is 1/3 capital B times H. My base itself is a triangle, so we have to think of 1/2 base times height for just the triangle. So like that other one we saw, so it's 4 times 6. So 1/2, 4 times 6. And that will give me, let's see, a 12 for my capital B. The H then is the height of the pyramid, and that is my 9. So then we just need to multiply all those numbers together. Oops, there we go. So 12 times 9, and then multiply by 1/3, or really you're dividing it by 3. So you get 36 meters cubed. All right, so now for this one on the upper right, we have 2 shapes. Now we have a composite figure, so we need to add the 2 shapes together. So we have first a pyramid on top, and your base is a square. So a pyramid volume we have as 1/3 capital B times H, so we're going to do that one up there. And then we also have the volume of the base figure, and that is a square prism, so we'll do that one next. So just looking at the top half with our prism, our capital B, it is a square. So we can just multiply base times height, or length times width, so 6 times 6, so 36. The height of my prism, or not of my prism, sorry, the height of the pyramid is 6, it's this one right here. So when I plug in my volume, I've got 1/3. Capital B we got was 36, and our H for our pyramid was 6. So when I multiply these together, I end up with 72. All right, so we're going to come back to that. So now we need to do the bottom one for the prism. And it is still a square for the base. And for our prism, we just have our capital B times H. So kind of the same, but not quite. So our capital B, again, is a square. So we're taking 6 times 6, so 36. The height of our prism is that 6 going up and down. So our volume we have, actually let's do it over here, is, let's see, capital B is our 36 times the 6, and we get 216. So now we need to add those two together. So 72 plus the 216, and we end up with 288, and this would be meters cubed for our composite volume. All right, for our figure down here, the triangle, it looks like a little tent with a rectangular or a square prism coming out of it. What you have to realize on this one is where is the base. So with your prism, if you notice, our prism, that the two bases that are parallel to each other are these triangles. So it is a triangular prism. And then we have a square prism. So if this is the base, and then it goes back, so we have two squares and then they're parallel to each other. So we have a square prism and a triangular prism. So if we want to find out the volume without that little square prism inside of it, we need to take the triangle prism and subtract the square prism from it. All right, so luckily both of our equations are the same. So it's a capital B times H. So we're going to break this down. So we have our triangular prism first. So our base is a triangle. So we need to use 1/2 base times height. Now, one thing you have to realize is with our triangle that it's 10 by 10 by 10, and we have to divide this in half, so that's really 5, and we have to find what the height of our triangle is. So if we use Pythagorean theorem with our 10 and the 5, so I'm going to have 5 squared plus b squared equals 10 squared, that I end up with my b. I'm running out of space here. So my height of my triangle right there is going to be the square root of 75. So we're going to be using that for our triangle part right here. So our 1/2, the base of my triangle is 10. The height of that triangle is what we just found, so the square root of 75. And my total there is 43.301. So that's our capital B. The height of my triangle prism is, think of spaces between the bases is 6. So my volume for this is, we're taking our 43.301 and I'm multiplying that by 6, and I end up with, let's see, 259.8076. I realize our total area of everything is going to be less than that because we're subtracting our volume of the square from it. Okay, let me switch colors now. So our square prism, this is the last part, and we have to subtract it off of there. So our capital B is a square, so it's just the 3 times 3. The height of our prism is, again, it's the distance between it, so it's still 6 right there. So our volume here we have as 9 times 6, so we get 54. So our final volume, we have to subtract our two numbers. So 259.8076 minus 54. And we end up with 205.808, and this would be feet cubed. So just realize we might have to look at subtracting out some pieces, and sometimes you might have to add the two pieces. It just depends on your picture.